Today we are going to generate a procedural asset. In this case it's going to be an asteroid. We're going to eventually turn this into a USD asset which contains several geometry variants, each with a unique shape and unique material and texture maps defined to that particular model version. We're going to use the Labs Maps Baker to loop through and automatically texture and extract any high-res detail from the final sculpt or the final procedural model, in this case the asteroid. And we're going to take the height and the normals and any other custom attributes such as the ambient occlusion, custom maps or any curvature maps that were baked into the high resolution vertex model and transfer them to a U-feed low-res model for each one. So if that's something you're interested in, stick around, because we'll soon put this into a USD asset and we'll have a USD asset with multiple variants that we can use in our work. So I'm working in the stage context and I have two LOP networks, and we'll just discuss the modeling one at the moment. As I jump in here, you'll see there is a little bit of configuration, but we'll just go straight to the SOP network in here like so. Now I'm going to generate an asset, like a rock asset. So this is like just one way of doing this. Say rock, it could be an asteroid. You can create very detailed looking geometry here with just a simple sphere, like this is the Labs sphere generator, and then you can just stick on a little bit of noise on here like so, and then you can start to subdivide this to give more detail. I'm just pressing W to see the wireframe, and then I'm going to blur the normals out, that when I create more noise it will average that out, and then if I add more normals on there you'll see a bit more detail. And it's just rinse and repeat at this point. I'll subdivide a little bit more, blur the normals, add more mountain noise, and then I'll subdivide one more time, blur again and add. So this is just one way of doing this. It does have limitations. It will eventually, break if you go too far. It'll start to collapsing on itself as well. But this is just one way of generating a really quick rock that's high res, and you can vary this now, which you could simply just vary this with an offset. It doesn't really matter how you do it. You could offset this and you'll get a variation really quickly of something quite nice. But it's unrenderable, so we'll eventually need to probably reduce this and bake it out. But this is just one way of doing this without any VDBs. But like I mentioned before, you could do a final conversion of this into VDBs. So this is just one example. I might use this, I might not. And then the second example will give us something a little bit more interesting. You can see it's quite processor intensive as well, so it's this is why it's good to automate this. So I've got this interesting looking one here, got some like holes in there and stuff. So this was again sphere, then I did a transform resize, add a mountain to give some generic shape to it, and you'll see I've got a double $F in here. That's because I'm just going to randomize this basically off this attribute, but we'll talk about doing this with tops in just a little while. Subdivide this, add a mountain to give some more noise, and then I'm going to convert this into a VDB. And then before I do that, I'm just going to poly reduce my original model and create some attributes on these points. So I'm just going to create an offset X and a P scale, which is just basically fit between different variables. So very, very simple stuff. And then I'm going to put this into a for each loop. So what I'm about to do here is it's the old-fashioned way of copy stamping. So you basically declare your attributes that you want to put on the points, and then you can manipulate the offset attribute with a point expression. There's a point for each begin that's essentially coming into here and saying offset. Then it will take that and randomize it between these two. So I'm doing the same for the P scale as well, which isn't needed on this particular. So I'm just fitting the points. I mean, they're not technically points, but there will be. I mean, there are points on there, so you can see in here that they will actually be points, and the P scale on here that gets randomized from these. So that results in one sphere being copied with random mountain offsets and just random scales. So you can kind of go to town with this. And then I created a VDB from this. And so we have the original one, and then I just cut this out. And I did a VDB reshape, smooth, and then I converted this back to a poly. And then I calculated a ambient occlusion mask, and then created some noise that basically is not affected by, it's basically multiplied against the displacement mult, which is actually the attribute I stored on this guy here, so I could just not affect certain areas to give a bit more contrast. Then I created new normals, and then I just remeshed the whole thing again. In fact, I think what I might do is delete the small parts first. I mean, extract the largest part here. So this is a labs tool, and it will allow you to extract the largest piece from this, just in case when you're doing these VDB conversions, you can get floaty bits everywhere. And then I'm just going to remesh this. It'll take a few seconds just to give a bit more evenly spaced triangles and things like that, because I'm going to do some further modifications on here. So if you've got a fairly powerful machine, you can kind of, there we go. So I've got a little bit more of an even distribution of noise. And then I'm going to create another ambient occlusion just to obtain another attribute, which I've called display scale. And then I'm going to use the triplanar, and I'm just going to stick on one of sidefx's metal textures and triplanar that on to give a little bit more detail, surface detail inside of the holes. Again, I'm not using any reference at this point, and I'm going to match the size and then just recalculate the normals and give this a name. I'm just going to call this asteroid, and then it'll be the name of the frame, so I could generate as many as I want. The the AN variable here is just something that I've got in alias and variables. I've just created you might see the AN. It was actually originally asset name, but it was just too long, so I shortened it to AN and called it asteroid A. So that's the asset name, and then the name of the frame. So once that's done, I'll create a rest position and just clean up all the attributes, so I just have normal and position. That's all I really need. Then I can save these to disk, and we will have variants that will change over time, because all I've done here is I've changed the mountain offset. So it's not the best way, it's kind of the old school way of doing it, but you could just literally now click save and save 50 different rock assets without using tops. And you could go and do the $F and the fit expressions in different attributes in different places that you want, and it'll work. So there you go. So there's just two examples of like different shapes. The final one I used here is actually, it is a top network. So I'm just going to come over here and open up this little top network in here. And I'll just navigate to the bottom, and I'll navigate to I'll show you the very end result, which may take a few seconds again to generate. So you may notice it looks crap. And that's because this entire network, I don't know if you can see, it's basically got these attributes called tops attri, and these are attributes that are called in here from my top graph. So I'm wedging them from here. So what I would need to do, because this is a fresh Houdini session, I would need to just come right click and generate the static node here. But I'll just do that here, and I'll discuss all this in a second, and then navigate to one of these here, and this will calculate the current wedge for me. I'll just talk through this now. So when this is evaluated, you can see it's been running for like 15, 20 seconds. So here we go, we've got this kind of asteroid looking shape. I say asteroid, I should have some reference, but I don't. I'm going to show you the process here is we bring in a box, and then I jitter the points. And I'm doing that now with this expression in here. This expression is linked to an attribute on here. So I have the top wedge. You can see I'm jittering random samples between 0 and 100, and it's a float attribute. So it's just going to give me different jitter shapes to just start with. I then subdivide the box. I remesh the box, get some interesting shapes. I then blur the normals, and then I do a large attributes. So this, whoops, this is just a mountain top with a remesh on it. And again, here I'm doing another thing with the offset. I'm doing the same thing. See if I can. I'm offsetting this again with another attribute down here, large shapes. And I'm basically saying, give me random samples, X, Y, and the Z from 0 to 500. So this will essentially do just that. It will keep randomizing, changing that. So this is kind of what I'm doing with these purple nodes, is I'm declaring an attribute on a particular node, in this case, the transformation. So again, I've done the same thing, but I'm scaling. And then I've done another one with the noise where I'm offsetting the frequency a little bit. And then I subdivide one more time, attribute blur, and then I add another noise on, just using an attribute VOP. This is just basically unified noise, basically going in and displacing the geometry. And then we'll add some more normals. So you start to get this kind of dense but nice looking shape, which can be randomized. When we click on the wedge, it will just start to randomize the attributes that fall above this network. So the next thing I do is I only reduce this a little bit, and then I just turn that into points, and then I give some random point attributes. So I delete the points randomly, and this again is just the percentage, and the seed is just how often and how many points are removed. Then create some attributes to stamp, and I'll just go through this really quickly. We can activate this off or on, and what I want to do is use these to copy, like we did before, copy some spheres around. Like little clusters, so they're like the little clusters that get put around here, like so. And I'm going to use those as like impact craters. So the way I've done this is basically I'm randomly deleting the points, and then I'm creating some attributes like seed, offset, and they're all promoted down here. And I've got depth, so I can kind of change how deep the points move away from the surface. So I've got the depth, so you can kind of see quickly view the points, it might be easier. think the recorder's slowing my machine down just a wee bit. But essentially I'm just creating points and I'm randomizing the offset of those by simply using the impact depth, and I'm using the translation of the original sphere that gets instanced, that gets copied on. So I'm randomizing the mountain, and that's why we get this kind of cluster of points that sit around the original geometry like that. So you can see we've got different depths and stuff. So just to give a bit more interest. Then that goes again into, like we did before, VDB, and then we'll remesh this. So you get this. Now this is randomized as well. So there's a group using the normal direction, and it's just going to randomize this on this axis. I should have really done it on all axes, but I've just done it on one for now. That's just going to allow impacts to be very dominant on one side versus the other side. So now we have the VDB. I'm going to do a VDB close just to kind of tidy that video up, and I'm going to convert this out and then delete the small pieces again, and then I basically remesh this just to get a slightly even topology on this. So we should now have very dense triangles, but at least fairly clean. And that's pretty much the few more features again is that I do the ambient occlusion. And I create a displacement attribute, and then I just adding more detail, and I reveal that by putting new normals on, and then I remesh one more time. Might be a little bit overkill, and you can imagine this gets really slow to kind of iterate over, but the idea is we're going to create a really dense kind of like high res mesh that we're going to use for displacements. So then I blur the normals one more time. I provide another attribute, this time displacement scale again, slightly different looking. And then we do a triplanar on this. And then we end up with this kind of final looking weird asteroid. And then just to not destroy my machine, I do a little poly reduce on this without visually changing any details, but it makes a big difference when it comes to baking. So there isn't much of a change in detail, but there is certainly a change in point count. Right, so that's kind of like the high res geometry that we would like to use to bake out. So you may notice the one last update to the normals. You'll notice this slow, and then there's a slow here and a fast. This is just while I'm developing. The fast links to this, which is a much quicker experience. When I'm wedging, it kind of tends to take a few seconds to give me the rough shape that I'm going to get, like so. So that's kind of what I had down here, is I just had a switch while I was just playing with attributes. So I think this might be set to high. I don't know. Okay, so next I do an attribute cleanup, and then I name the asset, and I'm naming the asset. I'm going to call this an because it's my variable, so that will resolve to asteroid. And then I'm using this at pdg index, which is just basically an index coming from here. So it's going to name this like asteroid. I'm going to go through and name this asteroid 0. So asteroid A _ 0. So just get a unique piece of geometry name, a primitive name called 0. Now, when you click on this, it does tend to evaluate everything through, because that's the nature of this workflow. There you go. So we can kind of preview this. So once we've done, I decided to bake in some extra attributes because I'm going to save this out as Houdini's native format, VGO, so I can measure the curvature using the labs curvature tool. We can get some nice curvature in there, so we can kind of quickly view cavity. So view the convexity. Well, we can use these for shading, and then I just did some custom maps. Might as well take advantage of having this and just created some custom attributes on here so you can visualize an ambient occlusion map. It's not needed, but you can use that later on for transferring into texture maps. That seems a little dark, but we've got another one using the dirt buildup just to kind of give a little bit more variation. So these are just placeholders really. There are other ways to do this, but because I had the high res geometry and this is going to get automatically baked for every shape to disk and baked onto low res, I figured I might as well stick it on there and see whether it's useful. So the asset's generated here, and then I'm just doing some adding attributes. I kind of make sure this is centered at the origin for this particular asset, and then I create a rest position. So I've essentially got very clean attributes. I've got my ambient occlusion and my custom convexity and concavity, my dirt, and then rest, and there is a CD color channel there, which will be there if you visualize the outputs of things. So you might want to catch that, because you might not want the color attribute in there. Always do an attribute clean and attribute delete as well to get rid of that. But that's essentially the large asteroid that's going to be generated procedurally, and I'm going to generate 20. Well, I'm not going to generate 20 versions of this just for this demonstration. I'm going to generate 5 because we want to then we'll dirty this node, and then we'll just generate 5 new ones like so. Same here, we'll output. So what happens now is we load the geometry into this file. Now it's technically not being saved out just yet, but this out save high res is going to go to this ROP geometry. So this is a ROP geometry node, so you can save geometry in tops, and I've chosen to save my geometry out. So you can see this node has been dragged into here, and it's going to export this to my dedicated location, which we'll talk about in just a second. So it's going to save that out, and then once it's done, it's going to load back in from here and poly reduce, and I'll just drag this through. You won't be able to see this rock at the moment because it doesn't exist. So, but what it's going to do is load in this high res geometry, which was generated from here, and poly reduce this, and then we're going to load the low res and the high res back into the maps baker. And on the way, I'm going to add some random vertex color to demonstrate something. And then I'm going to go into Tops Baker, and we're going to loop through and bake out our chosen maps for every single one, go through all the different folders. So this is going to make more sense if we just step through this, because it is quite a hefty setup. So what I will do is I will just go ahead and start generating this. I'll do generate static node, save, and it's going to go ahead and start doing it. So it's produced all the wedges that it's found in all of these promoted purple attributes, and it's stored them, and now it's going to save out this geometry. So this geometry is getting saved to on my computer, on my disk drive, my $job which is here, is a shortcut for saving to this location. So I've set my projects to my Patreon asteroid kind of folder. So it's going to save in here, and it's going to go into assets, as you can see, assets, and then $asset name. It's going to generate a new folder called asteroid A, which is the variable, and it's going to go into a folder called high version 1, and then it's going to be asset name and then pdg index and then bgo. So it's going to generate 5 versions of the high res mesh in this location for me. So it's currently chugging away there. Usually it's finished, but I think because I'm recording, it may be a bit slower, but you can see asteroid 1. So I'll let that tick away. Now, once that's done, it's essentially finished with all of this section up here, which I wish I'd not clicked on. And then it's going to load it into here. So I'll just talk about that as well. I'm going to cancel this and come over here. And now what I'm going to do is I'm going to create an attribute to use in this node here called at high res. So what I'm going to do is I'm going to take the PDD output, which is the output path of these files, and just convert it to a new attribute called high res, like so. And then I'm going to click on this, and it's going to use the attribute to load into this file path. So it's going to do that for each iteration it finds. So, and then we're going to save this low res out. So this is getting saved out down here. So it's going to drag all this data through here and save it using this node. So where it says the out save low res, it's here. And then the path is exactly the same as the high res path, but it's just up here like so. So low res. So we have the low res geometry being saved as well. So it's going to essentially take my high res, and it's going to poly reduce this down to something decent. I can't remember what I used. So yeah, just that's like a slightly detailed one. And then I'm going to create the UVs using this node. This is a labs node, and it essentially allows you to, because this is hard to UV, but it allows you to kind of chop up the geometry, and it will create an attribute that you can use called segment. So if you turn off visualize UVs, you can UV flatten this based on the segment edges. If I space 5, you can see it's cut them up, and then if I do a space a UV layout, you can UV layer them out. And I've just done very small rotations to try and pack them in a little bit more. So this has now got some UVs. You can do UDIMs and study the texel density and stuff, but it's going to become quite a long tutorial if I do that. So if you need to know how to do that, let me know and I'll show you. So we essentially now have a rock with UVs on. You can visualize the UVs, and it's going to save that down here to low res. And the reason it's called low res is once it's saved this path out. By the way, if you're middle clicking on here and you can't see the whole thing, if you right click and go view work item info, and if you drag this out like so, and then if you close it again, it'll remain open. So the output path is coming down here. So I've decided to take the PDD output into an attribute again and call it low res. So I'm essentially creating an attribute called low res, and I'm using that low res in here. So if I now view this file, this will allow this attribute to be registered, and it will load in here. So I can quickly see the low res geometry. If I'm displaying, I'm actually displaying the live network. But if I view the cached network here, you can see I've got my low res geometry, which is on disk. So you have the high res, and you've got the low res, and you can already see a sneak peek of what's happening with the textures, and we'll talk about that in a second. So essentially what's happening is we're able to pull in the high res geometry now from disk. TOPS has generated 5 iterations of this which match low res and high res, and we feed these into the maps baker. So before we do that, I decided to demonstrate vertex color, and probably why I don't use it. I am going to use it just for now, but I'm going to do a attribute cleanup. And if you feel you need more resolution in your mesh for vertex color, because this is like poly paint in ZBrush, you're going to be coloring the points, so the resolution is kind of defined by the points. It's a very old school way, but maybe you had a 3D scan or you needed to do something on the mesh. You can subdivide the mesh like outside of the top network just temporarily to get slightly higher resolution points, and then you can generate color. So you can basically clear the all the attributes. I think I'm going to just clear all these. I could have used these, but just to demonstrate something different, I'm basically going to flush out all of these. I'm going to measure the curvature like so, and I'm going to create an ambient occlusion like so, and then I'm just going to do attribute adjust colors using those maps. So just to quickly get some nasty looking vertex colors on there, so I'm going to do a attribute adjust on the ambient occlusion. I've colored some points randomly using some noise, using some old school effects, and then I've used the labs node to do some edge building, some edge color, and then I can use the color blends to kind of composite it all together, and it's not too painful. Then I'll do another attribute adjust color, and then I'll add some others. So essentially this is just totally optional, but I'm going to color this a different way, I think, but for now this is just going to be my diffuse color map that I use in Solaris in MaterialX. So essentially we've got a high res geometry that's gone into the maps baker. So the maps baker is used, it's called in here. So this is a ROP fetch, and what this will do is we'll fetch the ROP from within here. So all I've done is drag the maps baker into here, and I've made sure I'm executing the execute parameter name, which is this thing here, like so, on manual mode. And then I can output the result of this to this location, which is actually this location. So if you can see underneath the output directory parameter S and then output, that's making sure that this path that I've given here is respected and saved out. So the maps baker is going to be now fed in. It's already been done, but it's going to be fed in the low res and the high res, which contains some vertex color. Then I've chosen to close this down now. Chosen to output everything to this location. So it's basically my job assets. You can see up here assets, and then into textures, and then into an EXR folder 01, and then AN is the asset name, in this case asteroid A, and then the index is 0 to 4. So then it goes inside there, and I'm choosing to label the masks, the texture maps like this. The reason I'm doing this is later on, sometimes when you save a USD file, all the maps get localized and chucked under one folder in textures, and they can be named, they can have naming clashes, and things can be like map, like color can be named to color1 _1 color 1 _ 1 and it can get a bit messy. So I just chose to give each one a unique name just in case we decide to move those textures around. But all I've done here, as you can see, I've baked out the just a 1K resolution, and I've linked this channel to that channel, and I'm just using nearest surface, and it is previewing the color channel, which is the vertex color that was baked out. I'm baking out the tangent space normals from the high res to the low res. I'm baking out some thickness, some obviously displacement set to EXR, and then the custom maps. These custom maps were the ones we baked out way back into the mesh up here, so they could really have existed anywhere on this high res mesh. So what we do is we end up with the maps baker. Let me just quickly try not to end up with a maps baker here active now, and we can display this in here, but it's a bit weird that's not I can really understand. Oh, I see why you have, sorry, you have to put your display flag on here, and so what's happening now, this is just reading the results of this tool here, which just happens to output only the high res with the given texture map on, just for a display purpose in here. So what we've essentially got now is a asteroid asset with high and low res geometry and all the textures saved to disk, for all five of them. So I hope this wasn't too painful. So we can visualize the UVs on there, kind of quickly cycle through them. You can see we've got this vertex map, which I don't think is particularly great, and I'd normally use Copernicus now to do this kind of stuff, and I'm going to be looking into that. But this section here was just a temporary, put some vertex color, oh no, vertex color onto this geometry to bake it out. So yeah, so there is a bit of a difference between the final mesh and the vertex color as well, because of the resolution. So if I go and switch over to the stream on the right, which is the geometry, the high res geometry, the vertex color, and then I switch back to the low res geometry and the 1K map, you've got there seems to be like a color space issue there as well. I did drop the gamma to 1, and I'm not entirely sure if that would be a problem, because I think I can manipulate the maps within the material builder in the MaterialX later on anyway. And I would probably just do this all in MaterialX using the attributes that we stored in the maps. Because right now, when we put this into MaterialX, into the Solaris environment, it's going to be using this geometry. Okay, so texture generation. You may notice I have a top network called tops rat gen, and if we were to double click in here, you can see it would resolve to this little network in here. This is nothing special, and at the moment I'm still pointing to the EXR textures, but the idea is to switch my shader over to .rats so that when we start to run KarmaXPU, we don't have a delay, because it's already reading the rat files from within the MaterialX shader. So I thought I would just set this up. So all I've decided to do here, and let me see if I can just generate the static nodes here, is load the asset textures using a file pattern node. So I'm literally going to the location where my textures live in here, wildcarding the EXR folder, and then anything in there. So it's just going to go ahead and find them all. So when I generate static node, you'll see when I hover over here. Now again, if I just come in, let's have a look. I think you can write, you can go work info like that, and then just extend that. And you can see the directory. It creates a directory, an extension, and a file name, and then the actual thing called files here, which is the one that we're interested in. These are really handy, actually. It's a really cool little top node, this, but these are the attributes. It kind of does the job for you and partitions them off into these string attributes, which hold certain parts of the string, it splits up the extension and the file name, gives you the actual path to the actual texture as well. And then there's the files. So we'll take the files and we use that in a COP network. So I just basically use @files and it will resolve in here like so. So if I click on this, and then this is quite something to remember, if you click on this and then when you go in, you'll get the actual path. And you'll also be able to, if this view is linked to your viewport, if this was linked to viewport 1, it's probably going to jump up. If I jump back in there, we should see, when I enter the top, the COP network, you'll be able to see the textures as well in here. So if I just pin this now and press U, and I can cycle through the different textures like so. And these are the red ones. Let me just quickly go and show you the color correction. They're actually just a single float channel. So they've just stored, the maps baker has just stored this custom map, which would have been called something like, which one is this? This is the convexity. So it's just stored that in a float channel for us to use later on. So what I intend to do with these is I create I manipulate those attributes that we had, extension and directory, just to rename them and move them. So I basically create directory and I do a string replace, and I replace in question is the @directory attribute, and I'm going to replace the existing attribute with the same name. It's pretty straightforward. I'm just going to take the EXRs and turn that into rats. And then same with the extension, which was originally EXR, I'm just making it rat, and then I'm just going to concatenate, I'm just going to make a new path called new path, and it's just going to be directory file name extension. So essentially what that does is it creates this new path here. So I've already got the files path, the in path, and now I've just got the out path. And then I do a ROP fetch. So this is just fetching the results of anything I do in between the files in and the files out kind of thing. So the in and the out, and all I'm doing is converting them to rats, and the location is now new path. So if I middle click on that, you'll get nothing, but if I click on this actual node, I would hope to see the path, and you can see the COP network output underscore rats is literally just this null. So I usually have a script to do this kind of stuff, but I just thought, hey, let's use tops and just have a little setup here. So if I was to run this dirty and cook this node, it will just go through and create for the texture folder here under the asteroid asset a rats folder, and then it'll just do exactly the same structure, and it'll go through and convert everything to a Houdini rat format random access texture, which will be mapped, and it will be more efficient for rendering within KarmaXPU. However, we will need to point our MaterialX shader to this if we want. Right now, my MaterialX shader is still pointing to it will be pointing to the EXRs, because this was like a last minute thought really to do this. So that's just a little bit on what, if I just press U here, and again, U, that's just a little bit about what that bit is there. Again, you could have this whole thing running in one, but I don't require that at the moment. So that's just a little bit about the tops rat gen network here that we've got as well. So just to summarize, we have chosen a rock that we liked and gone into a top network, randomized 5 variations of it based off of variables which define its design, and then we've saved out the high res and made a pit stop while saving the low res out to poly reduce and auto UV, and then produce some temporary vertex colors onto the high res mesh, baking them and several other custom maps out, all via the tops network automatically, and then converting the rat files. So then if you want to preview the results as well, you can actually do something where you can bring in the path, like I brought in the path here, and I'm using this detailed attribute because I'm going to use this in a for each loop and an align. And if this doesn't like work or read correctly, I think it's mainly because you're not clicked on like this. It kind of resolves by having this the view existing. It's if you have to have the work item selected for this to kind of for the um detail iteration attribute and everything to work correctly. The detail attribute is I'm using the wedge total, and that's coming from in here. It's one of these variables. It's kind of using wedge total. So essentially it's just going to bring this in, and this is just a visualization. So I can just oh, didn't. So yeah, I have to kind of make sure I'm viewing this node here for this to work. But essentially this has just brought in those 5 versions, the low res versions, and then I've got the same thing going off for the high res as well. So that will kind of load in the high res geometry. So just so I could see, because you might have 20 of these, depending on your machine, this could be a bit painful, and it's just totally optional to be able to bring them in, switch between the high res and the low res, and you can see that the detail is being removed, the high res to the low res, which is what we expect. And hopefully our displacement will bring, and normal maps will bring all that detail back. So yeah, so that's just that's optional, and the rats is optional. They're just there's little kind of utility things. And then again, we bring in the low res using this pdg input context options iteration file geo1. This is basically going to read this file, the results of this geometry for every single frame. And what we're going to do now is have a little break, and we're going to talk about how we bring this into, we bring all of these rocks into Solaris. So we're going to quickly create make sure the actual geometry is very clean that we're bringing in. So we've got normals, position, and rest, and I'm going to give this a name. So I'm going to create a path that's built from this geo render and the name. So I'm just going to create this like so. So I'm just creating something here for what you call the purpose, the render purpose. So whether it's proxy or render, I'm going to poly reduce this because I want this to be my viewport proxy purpose. And then I'm just going to use a bit of a wrangle node just to replace the current path with proxy. So when I merge them together, they are put together in one, but they are defined by the path and not the name. So that's just the starting point for going into the Solaris environment. If I press U, we've come out of the asset generator here, which holds the tops graph, and the tops graph does daisy chain down to do a little bit more, which will trigger the final result of this network. Okay, so what we can do now is we have established a way of procedurally generating something, in this case an asteroid, and we've used the wedges and saved out the high res, the low res, and baked all the maps down this stream of the top network here. Now I've got to wait for all here, and what I'm having to do is wait for the maps baked with everything to be generated, and then I will publish the USD. But before we do that, we'll have to discuss how I've set that up. I also want to talk about this not being one like daisy chain network, because I seem to be getting an error that I can't work out at the moment. So we'll discuss that in just a little while. So before we leave the asset gen, I'll just recap that we did have this import low res files with this crazy PGG input context option, not options with an S, which is iterating over strings. This will create an index, basically like an integer value, a numeric integer value from the geometry it finds within the network. So you have to put this expression in here, like so. And then I'm doing an attribute cleanup in here just to make sure that I only send out what I want to the USD file into Solaris, and I'm just establishing a rest position. So I'm just keeping the normals position, the name, and the UVs. And segment edges is a group, so let's do a group delete as well, just to kind of clean up any other bits and bobs that I may have forgotten to catch on the way. There we go. And then I'll establish a rest just in case we do any, which we probably will do some procedural noise and stuff. So you want to make sure there's a rest in there. So it's nice and clean. And then just to recap, I created a path attribute to select this, a primitive path attribute to accompany the name like so. And I poly reduce this for the proxy. So I've gone quite low. It looks awful, but we just stick some normals on. And this is just for the viewport. Again, this could be a bounding, it could be a sphere, a bounding box, anything that just represents this shape. I think we'll try this and see whether this destroys my machine or not, but it's just going to be a standing in the Solaris viewport. And we then create another bit of vex here, which is just saying get the path and replace the render with proxy, and then it's the new path. So it just creates that. And then we merge them together and we're now finished here. So this bit was like a last minute thing, and I could have actually done all of this further up as well, but hey, you know, you can do a lot of different things in Houdini in different ways. So I've chosen to do that. So if I press U now, we come up to this part here, and you see at the bottom, and I'm going to just minimize this because all we need to do is click publish on this. I'm going to create a for each loop in here. And we're going to do a SOP import. So we're importing the out USD low res. If I just either hit Control, you can see that's pointing to the null. But if I go inside, you see it's pointing to this. I can press N and go up like that if you want. So now I'm going to say I need a primitive path. So I'm going to resolve that variable here, which is asteroid. And this crazy context option iteration is essentially an expression which will basically return the iteration value. So we'll get like, it will every time this saves out USD, it will cycle through the numeric value from 0 to however many we've generated, maybe 3 or 4, I can't remember. And then we do a layer save path. So we save this somewhere. And again, all I've done is just choose a location. So my asteroid USD is going to be saved somewhere here, and there'll be like another path in there. So what we can do is we can run this and discuss that when that's saved. So I created a thing called scopes, and that's just going to basically create at this point we have this, and then I create a thing called scopes. So before it's just this coming in, you can see we've got the two pieces of geometry here, and it just happens to be on the I must have generated 3 because it'd be 0, 1 and 2, and that would be the third piece. So let's just bring up the material, and I don't know why these are not on by default, because they're like the ones that I use quite often actually. Material and the variant, and possibly there is no purpose viewed either, which would be quite handy for the purpose. I then create scopes, so I just kind of organize them in here, and this is just using a primitive node, so not much coding needed. And again, I'm just taking the name of the asset and I'm just creating a hierarchy. So I'm creating a scope here which basically holds another scope called proxy, and it holds the geometry for the it's going to be where we hold the proxy geometry for the viewport for the purpose when we do preview or proxy and render. And we have the render version here and a materials location. And then I'm going to define the proxy here and turn that into a proxy. So I'm basically using a configure primitive node. And I think the only thing I'm changing is the schema. I'm setting it to scope, and then I'm basically copy and pasting the path from this. I'm taking this primitive path here and I'm copying that into here, and then I'm just appending geoproxy, and I do exactly the same with georender. So we essentially catch the geometry and reorganize this and declare a proxy and a render purpose mesh for the viewport. So, and then you can add you can change properties again. So this here again is just resolving, it saves me typing, it's just basically copying this, and I'm just adding attributes for like different subdivisions, and you can do that here. So this is something I might not be using, but I've just put it in to remind myself that you can change the divisions, subdivision types, and you can implement dicing as well using a render geometry settings node. So you can smack up the dicing a little bit on the actual asset itself, rather than having to do it at render time in the KarmaRender, which would do a global dicing unless you declared it using render settings, which I would probably recommend. But I just put that in there just to remind myself. So these are kind of optional. Then I created a material library, and inside it's just one material in here, which is very basic at the moment. It's got, basically it points to our textures that we've generated, and this map here is the same string we use in everything because it's kind of a procedural map. So it's just going to the EXR folder. Now, as I mentioned, I need to switch this over to rats maybe as a default. If I intend to stay in Houdini, it'd be fine, I think. But I'll just stick with EXRs. Houdini will convert this to a rat when we render, but ultimately I will be switching this to rat, or I'll have a little drop down menu in here. So I've added this custom string here called map name, and that's so that I can reference this map name, because my maps on disk are actually labeled the asset name and then the iteration and then the name that we declared in the maps baker. So the way I'm doing this is this asset name and context iteration is basically going to be like asteroid A_0, and then that's going to be the folder. Then it's going to create another name underscore the name of the map, which I originally had $OS to kind of take the name of this, but sometimes I realized I was copy and pasting this to do some other trickery and this would break the $OS. So I just figured if I had a consistent tag in here, the actual name of the file, I can reference that in this channel map name here. So that's what that is. So, and the nice thing is now I could copy and paste this and put that into my normal map and name this normal, and it would pick up, middle clicking here would pick up the name procedurally. As you can see, it's just going to pick up the names and cycle through because of this context options iteration expression. So I haven't done any look dev. That might be a separate tutorial. This is just kind of placeholder for one material. So I may have got some junk in here. Let me just get rid of that. Don't think we need the inputs too. So essentially the color map comes in and it's signature color, and because this was the maps baker, I set this to sRGB texture. It seems to look a little bit better. I may need to look into that. And then I just played around with some color correction. Again, I'm not really precious about the look development at this stage. It's just about making the system work. And then I just cheated, separated the color into the red channel, and then I just did like a bit of an invert and a clamp to get some specular roughness in there, which again can be done other ways. It was just a really quick hack just to get some surface detail on there. We use the normal map, which is always a vector 3, and I believe the color space would just be raw. And we put that through, and it's a tangent space normal map, so we just use the defaults. Then we use the height map, and that is a float and a raw. And again, so this string is exactly the same here, and here it's just defined by the map name now. So we can then set a scale, and I've added a material geometry property value here and called this scale disp, because I'm going to see whether I can manipulate this later on with like varying point instance attributes. So I could have like the same asteroid but with different levels of displacement, or I could even do this. I've done this before actually. I used quite a few of these, and I randomized after the fact, everything had been instance. I randomized the colors and the specular, and it just turned one material into a slightly different version of itself. Like I could change the hue between certain values, so you could get slightly different shifts in green and things. So I've just put that in to remind myself that I might be doing that later on. It might not be in this project. So we plug all this lot into a MaterialX shader. Now I know there are scripts that can do all of this. This is just a placeholder. I have a much bigger template that we can discuss when we do some actual look dev. This is just is this thing going to work? So it's just one material. We've called it iron. I don't know why. In the material library. And if you get this, it's simply because we're not actually cooking the full loop, so it kind of complains a little bit. But you'll notice now in the material it's been assigned to the asteroid A, and it will cycle through when we save this. So we configure a layer and we save the materials out as well to a location of our choice. So you'll notice I've got the job assets and then the asset name in USD. This folder will be created, and then I've just created a version, and I'm defining that just simply on here. I've added a custom string here, and I've created a version parameter. I always find it's safer to just version up your USDs when you're iterating and playing with this. You're going to get rid of those. So at the moment, this will just essentially loop through and assign this material library. It will bring this material library in to under the hierarchy here. So it's going to say the primitive path, I want you to go and place this node, MaterialX, I want you to place this under this location like that. So we essentially do that, and it's going to iterate around all of the iteration values. So we should essentially have a shader for each, a shader that contains unique materials for each iteration of the rock it finds. So then we do an assign material, and again that's just making sure that that gets assigned using, again, this custom asteroid A, and then this huge expression which is just the value here. Then we just say where is the material, and it's just there. So you know, you could have used $OS here or op name or anything just to pull the name of this, but I've just hard coded this in for now. And we will look at iterating through different materials. So we've got like different materials for each asteroid as well at some point. We then add variant to the asteroid A main asset, which is what this thing will be called. We create a variant set. It's going to be called model. And then we're going to essentially just fill in these with the values that we need. And then I'm going to use the wedge count here to kind of loop through the amount we declared, the very top, I think, in the wedge node here, which is wedge count, which this actual, I'm middle clicking at wedge count is coming from an attribute in here, like an index attribute, sorry, a integer attribute 3. So it's just going to iterate through that. So if I can't remember what version I'm on, to be honest. I think we can do version 1 because I may have flushed everything out. But what I can do now is come down to here. Now everything's generated and I can generate the static node and then hopefully dirty and cook this node. And this will go ahead and run everything through on disk. Oh, there it just popped in there, USD asset. So I've got version 1 and then I've got the actual main asteroid asset and I've got the layer saved details. So I've got the individual asteroid assets here, which are just USD files at this point. Then I've got the material assets, which are a USD-A, but actually read if this is working. So we should see, like in the materials, it should start to list the color for, like, yes, it's listing the textures, the EXR file paths is color. It's asteroid A0 color. So it's picking up the right texture map without me even checking. I can just look at this and it's picking up the right texture map here. Which basically what this means is that if I now bring in if I take this, copy this, and I select this asset reference, but I realized I had within the USD sanity, which is just the asset reference, I had a variant that didn't exist. So I was probably viewing a variant from a previous iteration, tutorial or iteration wedge value, which was going up to a range of 6. So if it goes blank, just make sure, it catches me out every time. Just make sure that you can find it. So essentially you can see now we've got this like proxy geometry in the viewport here. If I go final render, it'll switch that out to the high res geometry, which is the kind of semi-poly reduced mesh which holds the texture details. So there's one version and then there's the other version. So obviously you can make as many of these as you want, but it's quite nice because that's what renders at render time. So switch back to preview, and at least you get a rough representation of the shape. This might be a bit overkill and the render purpose may be a bit high res. So I hope that you can take a look at this anyway. I'll stick this on in the HIP file. It'll be there for you to look at. It's not perfect and it is complicated, I will admit, but I am going to look at creating a version using the component sidefx as component builder, which, you know, you could do all of this by just creating the geometry variants. So you could have asteroid A and then you could bring them in manually, but if you keep making a lot of these, you're going to have a lot of individual ones. But sidefx have made it so you could like bring in asteroid A and then plug that in and make that B, and the geometry variants for the asset, whatever you declare, would become this name, and then you can make as many materials that share the asteroids, or you can make materials that are specific to the asteroid shape. And that's kind of like really nice and easy to use, but we would lose the ability to loop through. So I'm going to do a version where we just plug in one and we can add multiple materials as well. I haven't worked this one out yet, but that's what's coming next. But for now, this was just a quick way of doing this and getting a bunch of tops generated procedural piece of geometry, in this case this rocky asteroid. So I've got an explore variants just to kind of take a look and see. We can just explore and look at them, and the switch node is just toggling between live, cached, and exploring the variants, so nothing really worth saying there. And then I've got instance assets. Again, I've basically created a destination to put this in. It's an explore variant, and the source primitive is probably coming from here. So it's just basically saying asteroid A. Here, destination is this instant assets. So we've got them instanced, and then I'll create a collection from that. The collections node here, we've got like the same thing here and here. So we can click on this. You can see the collection name is called instances, and I'm just basically looking in the hierarchy and just grabbing, well, anything within. Yeah, so I'm going to create a bit of a lineup here. So let's take a look at what we've got. In here, I've created a wedge attribute. Now, I don't think that's the best way, but if we do click on this, it will generate 3 points on this line. I'm just taking advantage of having this attribute in here. I'm not sure it exists anywhere else on the geometry or anything. I'm just going to turn them into points, and we can spin the instances. So we look at the, I'll just minimize this for now so we can see the code here. So this is just a very optional thing I just like to do sometimes. You can click on here, and we should see the particle origins. I'm sure this is a bit of a weird, there they are. They were just disabled by some other thing here. So you got these instances here. So I'll just Alt P, just bring this up here. And if you look, it's just going to spin basically 360 degrees, and there's a spin speed. So you can slow them down like so. So I could say 50, and it should technically loop almost. And then I've created this attribute displacement scale where I'm just randomizing the displacement of each point, which we'll talk about later in the shader. And then obviously just standard instancing attributes where you can use p scale to randomize the p scale. So if I just jump up now, and if I just press play, you can see we just got some asteroids spinning around. So nothing too fancy there. I then put a light in there. And then this is a something I was just playing with. I was just exploring with this scale displacement, which was going back to the shader up here to try and pull in this attribute and randomize the displacement height. So I just press U twice to come back out. So I was just declaring it in here and randomizing it, and then hopefully this works. I think it might work without this. I'll have to double check. But I was just going to randomly just change the displacement just as a test, and I don't think I used the material variants. So here I'm just spinning the lights. Again, just a very quick expression in here just to spin the lights, but you can control the speed of the lights as well. But if you're spinning the instances, it might look a bit weird. So it's just to check things out a little bit. I've created a camera, and I've got this look at me constraint. So I'm basically just constraining my camera to the look at me transform node here, which is there. And I'm just setting the camera back a little bit. So hopefully now we can look at the camera and we can see these things spinning around a little bit. And you can see they are very low res because they are the proxy in the viewport. So if I just switch this to final render, you can see that that's the final render. Well, the final render purpose, that's the geometry we're viewing. If I press W, you can see the dense meshes. If I zoom in, you can see that. And then I can switch to the preview, which is a proxy, which is pretty handy for like just laying out things in the viewport. And then again, I've created some KarmaXPU AOVs, and I've done the crypto mat, and I've created one called comp and utils, and the comp is usually what I define as the when I break down the render and rebuild it in comp, I use things like the direct volume and indirect volume as two separate passes, and extract things like the direct diffuse, the indirect diffuse. Depends what I need for the project. Because this is just in the modeling stage, it's not really that important. But I sometimes have these active when I'm doing the look development because they're very good for kind of peeking at the render and having a look. So if we hit render now, there's a bit of a delay because what happens is the textures in here in the right color space, the textures that were saved on disk, the EXR, are actually converted to rats. So because we've got 3 EXR textures active in our iron material, we have the color. In fact, let me just show you. We have the height, the color, and the normal. Houdini will just automatically convert those to rats for you, which, you know, we could literally convert our own rats as we did earlier. We could have had a rat folder that we could have pointed to later on if we want. So just bear that in mind. There's a bit of a delay, but once it's done, it's fairly responsive. It's fairly quick to keep updating things. So this is just a way of just testing how things are looking at the moment. So they're very low res, and the instances are just temporary. They're just spinning around, and I'm just basically able to just nudge the lights around just to kind of get a feel for it. So this is totally optional here. It's up to you. And if I go back to these AOVs, you can see that the ambient occlusion AOV. You can see the albedo of the textures, and that's the vertex color. So they're not going to hold up too close, but that's down to you. You've got combined glossy reflections. I have crypto matte materials and crypto matte primitives, which will be pretty much the same at this stage. Direct diffuse, and then probably no volume at the moment, but we've got things like the UVs. You can see the UVs, so that you can actually retexture things using UVs in comp as well. So there's a lot you can do. So you can choose which ones you like, and I choose to do it this way, so I can plug them into the second input, import render bars from the second input, so it imports them down so that you can still pull in the filters, and you can choose which ones to denoise as well. So when you bring your final EXR, let's call it the beauty pass, with all of the hidden AOV channels in there, and you extract them, like, they're not noisy because they've been denoised. So you can actually just start comping without having to denoise things as well. So you can choose things to denoise in here as well. But again, this is more like look development and lighting. This is just like a place I've called modeling for now, just to do stuff. It's a bit of a fine line because you would technically be modeling, procedural modeling, and then doing some look development. But in much larger pipelines, you might not even do the look development here. You might just pass on the USD model to look dev, and they may then cycle through their own little setup and things. So, but if you're an independent artist, you might just be wanting to do everything in one swift move. It's totally up to you. There's a lot of flexibility in USD, which is really cool, and I'm learning quite a lot all the time with it. So yeah, so what we can do in the next video is just create a little scene and have these. We'll get a camera flying through these, and we'll create more than 3 versions. But what's really nice is we could actually set up the entire scene with the same asset here, with an instance, just 3 of them on, and set up the camera, take a look how it's looking, and then later on just generate 60 different versions, and they'll all replace, you know, the instance will replace the certain point, rather than just being a copy of 3 variants across the points we use, if that makes sense. So yeah, it's not bad for, like, you know, a few minutes. I mean, it's quite complicated, but hopefully we can kind of keep working on this, and this could be, you know, inside of here, it could be pebble generator, it could be rock generator of any type of rock you want. It could be tree generator, and we could start to see how we can procedurally go down a route, or even pull in 3D scans and manipulate stuff and add and bake, extract height and normal maps and generate procedural color. Maybe have a little pit stop off in Copernicus. It's quite endless and quite fun, but there are some quite tricky parts to work out, I'm afraid. So yeah, because we're looking at this camera, I could rotate the actual camera around the objects as well, just if we wanted to do something crazy. I don't know why, but if you mess up, you can hit Control middle button, mouse button, and it'll just reset that as well. So we'll leave this tutorial here, and then we'll look at putting this into a little lighting scene, and then we'll call that finished, I think, for now. Hopefully there's some tips and tricks we've both learnt along the journey. Thank you. Welcome back. Okay, so now we've kind of gone over the asset generation, and we just have a asteroid asset generating three versions, so three model versions. We are now going to just take this asset and put it into a little lighting scene. So I'll just go through and talk you through this little setup here. So just to give you an overview, we have the asteroid coming in here, and then we have a camera with a curve, and it follows the path with some noise on the camera. We instance that onto the points that we generate actually within the instancer. We can cache the scene out, and then we can add a sunlight, nothing fancy, and then we can start to add optional fog if you want, and we can add some AOVs and then render and apply a motion blur lop down below so we get the correct motion blur. So from the top, we bring the asteroid in. So this is actually just linked to the output from within the modeling thing here. So normally you wouldn't link directly from here, but because this is all in my scene, I can kind of just link it there. So I can space G, and you've got your model, no transformations on this, and I just to test it was working. This is not necessary. I can just switch between the different model variants by looking at the proxy purpose in the viewport. That is not needed, and it will just, if you don't have that, it will just default to the last variant that was implemented within the loop that we established in the modeling section. We can make this instable, because that's what we're going to do. And then I'm just going to put a configure layer. I'm just going to save this to a location so that when I cache this, it just makes sure that this asset is saved to disk. So I'm going to create an explore variant, and source primitives, they are literally called GeoAsteroid. And if you look at this little line here, this is because I've got this view dependency links for selected nodes enabled. So I can like see that I've actually linked the path here, destination path. I've gone copy, parameter, paste relative references. So it's saying, look at these primitives in here, run this lop on here and give me a destination of geo, and then $OS, which is asteroid library. So if we look down here, we're essentially, all we're doing is we're bringing in the asset and we're extracting it into separate instable assets, unique assets based off of their model variant. And there's only 3, but we will get this working, and then we will crank it up in here to be like 40 or 60 or however let's just see what happens. So, and then what I've done is I've just added a bit of Vex code here. So I added a collection here first. So that's just, it kind of just, collections are really nice for just bundling up like data sets, lots of information in a variable, like in this case instances, and you would use that later in other nodes just for convenience. So I've just literally gone to the geometry library here, and you can control and click to open up a little menu and select one and click OK, and then just wildcard that if you want. So it's a bit like hand picking this, and that's really nice because you can actually go and pick your favorite variant. If you've done some look development, you had a little contact sheet, you could label the contact sheet of the renders and then just pick the ones you like, or just filter out the ones that you think will work. Or you might even have different variants within the same USD asset that you might want to filter through. So I'm just grabbing the whole thing there. So my collection lives here, and the includes of the collection, as you can see, are just these. So they've got an index and they're basically just those. So I'm randomizing the color, and I'm just doing it again on that collection. So I'm doing modulus or percentage sign, whatever floats your boat. You can call it anything. And I'm using instances. I'm just randomly coloring the point. why is it not working? That should have worked. Did I do something wrong in my code? Just see, do I random trim path instances? Oh, that should work. Should have worked. Don't know why that wouldn't work. How strange. I think I know what it is. I think it's because I may have chosen to instance it at this point. I don't need to do that, and that just might be breaking this code. So yeah, all I'm doing is I'm just coloring each one. Now there is some kind of viewport thing going off in here. I keep getting that quite a lot. If I reset the view, actually you can see 3 colors, but yet we seem to only need, it does tell me there's 3 in there, so I'm not sure what that is. Let me just take a look at this. Explore the variants stacked. What is that? Maybe explore variants 0. Maybe that's better. That's strange. Okay, so I'll just do an explore variants with no spacing and justify them. I don't need to justify each one, but I could just say center them because I want that point to be, you know, in the center when it's instance and doing some spinning. So apologies for that. I must have just rushed that part. Now, if we instance them, I can instance on using the modulus instance, which is my collection. So you can see now if I look through the camera, we've got all of these instances on. So I have a curve in here. I just drew a curve, nothing fancy, and then I've just resampled it a little bit. And I don't think I need the orientation along curve at this point, but I just put that on anyway, just to give normals along the curve. And I've created a bit of noise on the curve. You can't really see that, but the curve will ever so slightly just move, just to kind of replicate a little bit of motion camera shake or something. So you can see the camera is, you know, the curve is just moving a little bit. Totally optional, and that's just using a anti-alias flow noise that I'm just using against the time. So I'm just adding that back on, and I've just promoted the parameters here. So that's pretty much my camera path, and then I'm going to output these points for my instance because I want to just very dirtily scatter points along this curve so that they only exist where the path is, just temporarily. So there's my geometry for my curve, and then I add the render camera, and I've got this follow camera path here. And all I'm doing is I'm saying the source is the camera. So I'm taking the name of the primitive path here, and I'm just basically grabbing that here, and then I'm saying target the curve, and I've animated the position and the roll, and then the lookup mode is on Y. So if I don't hide the target, you can see the camera is going to roll along. See from here, you probably can't see anything, it's just a black viewport. But the camera is going to travel along that path. There he is. It's just traveling really fast along that path. And then I added I added a point constraint in the next form, and then I just right click and did some motion effects and just added some noise, and it creates the channel here, which allows you to kind of create noise on the on a given channel, so on a given node. So I can say like, this is the channel, this is my noise functionality in here, and you can basically control like shake on the axis of the transform node here. So I've got like a rotation noise and a translation noise being fed into these X forms, which are just sitting basically then this camera is going to be influence parent constrained to that with relative offset turned off. So it's basically, I don't know if it's quite fiddly to, the camera will do a little bit of shake on the translation and the rotation independently. So that's what these two things are. So they are completely optional. The follow path would need to be there, I think. And so is the kind of wobbling on the curve is just optional. So essentially what you get is you get like a bit of a shake on the camera as this is kind of passing through. And now we'll discuss the points. You may have noticed there's some points in here like that kind of follow that camera curve, that path, and that's nothing fancy. It's literally, you look at the curve, which is difficult to see, but there it is. The instances like follow that curve. So I'm just going to, I can just hide target for that, and then I'm just going to jump in here, and I'm inputting the curve that we found. Like you can follow it, it's just up here. So I'm just bringing that in. And then I'm just going to resample that curve down a little bit, and then I'm going to just sweep it like so. So I'm just using a very basic shape here because that's where I want my points to live. We don't really need the normals. And then I'm going to do a points from volume. That's going to just basically scatter the points. There's a little bit of point separation here that controls like the density. So the higher you go, the less dense points you'll have in this area. You can jitter the seed, you can jitter the scale, so you can have no jitter, and then you can jitter them around. You can divot the surface, which if you do 180 dither, it's going to kind of fragment them off a little bit around the edges. This is just really throwing things together. And then you can change the density scatter a little bit and relax iterations as well. So you just get like a ton of points. And now because the camera is above this hierarchy, if I ghost the other information, it will let me see the camera. So I can kind of see roughly how the camera is going to travel through these points. If I hit D, I think is it in here, the visualization of points? It's not very useful at the moment to me, but I could say lit spheres, and then you might be able to just see things a little bit more clearly, how we're moving through that path. Points. So then I do a polywire, and as you can see, it's polywired very closely to the kind of edge of the camera for stream, so that I will create a volume from this. Then I'll create a group, and what this is going to do is just group all the points that are very close in the middle of this point selection here just to delete and remove them so that they don't fly into the camera. So I'm just creating like a pathway. I'm clearing a pathway, I guess, that way. So then I create an ID from my points, and then I create a generic p scale using the attribute adjust float. So I do the p scale, and I now scale those model variants from 0.1 to 1.5. It's a little bit extreme, but hey, we'll see. And then I do a randomization an inside sphere, so you can see all the randomization orientation happening here. And then to avoid any like overlap, I do a relax off the p scale and relax in 3D space, and you can kind of change the point radius, so you can relax these so that they don't intersect with one another. It'll try its best to do that. So if you see that they're intersecting, you can fudge this around a little bit maybe. And then I created a noise, which I actually just called noise, and you can see it's like this. And then I'm deleting based on noise. So I've basically written a little bit of X code here, and it's going to let me view this, but it's going to delete based on a threshold, so I can kind of do that and invert that as well if I want to do that. I can't remember how we had that set up. So you can just get an interesting shape points that we can quickly look through and kind of art direct how you think that might look. It's going to look cool or not, or if you think it's too many, or so you can art direct the shapes in many different ways. I then did another cull, and this is just a percentage cull, so I could cull all of them or not, and it's great for testing. And that won't affect the distribution of the instance because we're culling based on the ID. Yep, and then last but not least, I'm spinning the asteroids just randomly around, but that needs to be updated. Actually, I need to fix that because I think they're all going to spin the same speed. So what I'll do is I'll throw the updated code into the project file, and that will spin different speeds based on the p scale and things like that. At the moment, I think they're all just spinning in a loop. I've just stolen something. I don't think I've got any of my codes in here at the moment. So just to kind of get some points out, I've done that, and I know you can cull points based on camera, and I'm just doing this to do something different. So we end up with this, and you can see the bounding boxes are green. The instances that my machine isn't handling that, so you can see it's trying to instance them as we fly through. I then use a file cache, and I choose my location. There's nothing special here. I'm just basically going to save this out because I think it's a bit more efficient just to save out the scene at this point. And then I believe you need a cache here to cache all the frames just to kind of help with the motion blur calculation. Then put a sunlight in, and then the rest is just adding crypto mats. Now I've added a crypto mat based on the ID, so I'll quickly just render a frame. So there it is. So we've got motion blur firing off here, so I could just hide the light in the viewport. And because we've got an AOV for crypto mats, comp and utils, which I may have briefly discussed earlier, this is totally, you could have this all in here or in one. This is totally up to you. I can kind of go in and look at my crypto mat materials. You can see they're actually just 3 materials, and there will be 3 objects at this stage as well, primitives. So yeah, and then they should be now a ID. So there's a unique ID. So if I wanted to grab this particular one in comp and then add some more texture, I could use that in conjunction with my UV pass, which is in the utils in here. So you can put as many passes that you need. As you can see, I've just like ticked every box because because it doesn't really add to the render time. And then the AOV comps, you can do light per light passes if you want. You can declare on your light, you can go and enable the light tag and give it a name, and you can split based on light names and all sorts of things. So you can really go to town on this. So yeah, so that's the render. So that's pretty much this scene, and the whole point of this scene was just to test this variation out. I mean, we have 3 and we're getting quite I know it's a very low quality render, but we are getting, you know, quite an interesting lot of shapes out of there. So I'm just going to render this with 1 diffuse pass, and we're not using the volume at the moment, so I'm just going to set that back here, because we could put a volume in here if you wanted, and then you could scatter bounces around. We're going to keep all the settings pretty much default, and then I'm just going to denoise some of my AOVs that I'd use in comp. Again, you can choose the ones that you'd want to denoise. I'm going to use quite a few samples, and I'm not going to use full HD. I'm just going to set this to the HD 720 mode for now. And then I'll do a render to disk. And this will return, because I've got this monitor here, it's got enabled mplay switched on. It will render it on disk, and then at the same time show me in mplay, which can sometimes add to your consumption of memory, so you might sometimes want to turn that off. But yeah, you can see the rotation isn't great. They're up pretty much. I need to improve the rotation, which will help the randomization. But also there are only 3 models in here, so you can sometimes pick them out already in here. But as soon as we fix the rotations and we add more variety in here, you're going to get this really crazy amount of asteroid fields. And this is taking 10 gig just to render, and you can see the render times are not, hopefully my machine's still recording. It's not crashing, but it should handle it. And I would normally just render my projects, like personal projects like this. I wouldn't try to render stuff 4K or anything like that, or HD, maybe HD, until I'm really happy with something, and then maybe I'd send it to a render farm. There's really cool render farms, but you have to put your hand in your pocket, spend money on those. So what I decided to do was render this and then upscale this using some AI upscaling software, just to nudge it to HD and sometimes to 4K and see whether it's going to work or not. So but that's not really a Houdini tutorial. That's more like post-processing your comp after you've rendered everything from Houdini. It's gone into comp. You could upscale that maybe. It depends. Sometimes I just nudge things to HD, and then it just goes on social media, and it's just like a log of just here's a proof concept or something, or here's something I was testing, and I stick it on social media just to remember this is the date when I did that. And I've actually done that before, otherwise I'll forget. So that's the end of the tutorial, I guess, of just basically procedurally generating an asset, baking out textures, and then uniquely creating a geometry variant with a unique texture associated with those particular UVs on that particular model variant. We didn't use all of the texture maps we baked out. They're there on disk, but hey, it's great to just have more than you need just in case. And we didn't really use Copernicus at this stage, which is stuff we're going to, there's so many things we can start looking into. So when you get this file, you'll find that the randomization is a little bit better, and you may have to generate your own asteroids, and then just to keep the file size a little bit smaller, you'll just generate your own USD assets and then update the scenes. But hopefully this you've learned something from it. I certainly have had fun, and I'm still learning loads. And even doing this project, I can see how things can already be improved and things. So but that's Houdini. You can't claim to know everything. So yeah, it's not rendering too slow. I think my computer is recording, and it's taking like 2 minutes a frame with motion blur. So it's not too bad. But yeah, I'll probably stick this render up at some point as well. Maybe I'll comp it, I don't know. Anyway, thanks for your time, really appreciate it. Take care.